Hello enriched students, Marsh here. So I'm going to do one example from your worksheet so you guys can get a couple of, so you can talk through it a little bit and so you can kind of understand how and the conversation that I basically would have with myself to be able to graph this. So on every single one of these examples, guys, you're going to want to, or problems, excuse me, you're going to want to find what's known as the parent graph. Now, your parent graph, guys, is what's going to be inside the parentheses. So in my case, my parent graph will be y equals 1/3 to the x power. Now, what I'm now going to do, guys, is make my little chart over here of my parent's graph. Now, 2x values you're always going to want to plug in is 0 and 1. Those are the two values for x. They're going to plug into every single parent graph on every single one of these graphs, okay? So if I plug in 0 into this, 1/3 to the 0 power, well, anything to the 0 power is 1. So that's actually going to be a pretty constant number or value that you're going to graph. And then 1/3 to the first is 1/3, right? So then I'm going to graph that function. So 0, 1, 1 1/3. So it's going to be something like this, and it looks like it's going to go kind of down and swoop. Just like that. Okay? Now, I need to now do some transformation. So, always graph parent. Number 2, you're going to want to do your vertical stretch or your vertical shrink, depending on what it is. Usually we're going to look at stuff with stretches. So in this case, I'm going to stretch by 3. So to stretch by 3, actually what you're going to do is you're going to multiply your y's by 3 because you're vertically stretching, right? So if I'm vertically stretching something, I should be multiplying the y's because that's my vertical amount, right? So I'm going to multiply my y's by 3. So I'm going to get 1 times 3, that's going to give me 3. And 1/3 times 3 is 1. So ultimately, guys, the graph I'm now going to graph is going to be 0, 3, and 1, 1. So 0, 3, 1, 1. Okay, let's connect those two dots here. There we go. Now, I need to take care of the last part here. Let's go purple. I need to take care of my shifting that is taking place here. So, if I go up here, so let's go here, shifts. So, this -2 up here, since it's in the exponent, remember that was kind of almost like when it was in parentheses, when we were squared or any of that nature. This is going to move us right 2, and this is going to move us down 1. So, right 2, down 1. Now, that is from my blue line. So always go from the last line that you just graphed. So right 2, 1, 2, down 1, and then right 2, 1, 2, down 1. So now I'm going to move my graph just like this, like that. Now, what kind of graph is this? Is this a growth or is it decay? That's what a type means. So this is a decay graph. 2 ways to know that. A, my graph, it looks like a slide, thus it's decay. Also, my parent graph, the value right here is less than 1. Thus, I have a decay graph. Now, my asymptote. Where is the asymptote located? Well, normally, on my normal graph, it would be located at 0. But since I moved down 1, my asymptote has to move down as well. So my asymptote is going to be here at -1. So my asymptote would have a value of y equals -1, because that is the graph, that is the asymptote's equation, y equals -1. My domain, guys, -infinity to +infinity. I am going and covering all of it. And my range, this is where a lot of kids kind of have a sticking point. So I am not crossing -1, right? So I'm going to start at -1. Notice it's parenthesis because I am not crossing it. And then I'm going up to the positive. So it'd be -1, excuse me, to infinity. So my range, -1 to infinity. Now guys, something to be aware of, your domain is always going to be -infinity to infinity on these graphs. Your range will always include your asymptotes value. So something to keep in mind as you're continually graphing them today. Now what I would like you to do, guys, is complete the rest of the 7 problems on this worksheet. Make sure if you want to use multiple colors, or at the very least, please mark in which one is the final graph so Marsh knows where it is. Ultimately, guys, you do have a video tonight on real life applications, which is basically the story problems of this stuff. So you can also complete that so you don't have homework overnight. But that's the end of this little example video. See you later, Sabers.